Hello, everybody. Today is basically going to be a practice day. A lot of times students struggle with Stoich because they don't know which converter to choose. So we're going to take a day today and do a little bit of a recap of the past 3 lessons, and then you'll have the rest of today to practice. I'm going to start off with one example, and then you're going to try one on your own, and then you will have the rest of the today to practice. Okay, so example 1, 27 milliliters of 0.5 moles per liter of silver nitrate is combined with lithium sulfate. So the first thing we're going to do, like every single problem, is we are going to write a balanced reaction. So silver nitrate, AgNO3, is aqueous. Because it is in solution, we know that it's in solution because we're dealing with molar concentration. So you do need to use your page. You need to use page 6 in your data booklet to determine if it is soluble or not. Okay, and it combines with lithium sulfate, so that's Li2SO4, which is also aqueous. This is a double replacement reaction, so it will end up with lithium nitrate, which is aqueous, plus silver sulfate, which is solid. Remember that you do need to balance, so we're going to have 2 and 2. Lovely. Okay, let's go ahead and look at the first part of this question. Determine the concentration of lithium sulfate. So I'm going to first label my known, and my known is going to be this guy here. So it is 27.0 milliliters, 0.500 moles per liter. And then we also have some other information here. Lithium sulfate, we have 14.5 milliliters. For the first part, I will work in pink. We are looking for concentration, so moles per liter of lithium sulfate. So let's set up our Stoich. First section. Start with what we know. So 27 milliliters of silver nitrate. And then again, you can convert this into liters if you don't like working with milliliters. And then we're going to use our concentration, 0.500 moles per liter. Liters cancels out. I have millimoles. As long as the base unit is moles, we can then use our mole ratio. 2 moles of silver nitrate to 1 mole of lithium sulfate. Okay, so mole cancels out with mole, and silver nitrate cancels out with silver nitrate. And then lastly, all we need to do is divide by our volume, 14.5 milliliters. Milli cancels out with milli, and then we are left with moles per liter of lithium sulfate. So our final concentration is going to be 0.464 moles per liter. Great, let's move on to the next part. Determine the mass of the precipitate formed. So I'm going to go and grab that same reaction because we're going to be using the same reaction. Right, so we will be using the same reaction. However, now it wants us to find the mass of the precipitate. So we no longer are worried about this as being our unknown anymore. We are now looking for grams of our precipitate. So we're going to start off with the known that was given to us in our problem. Yes, we do know the concentration and the volume of this guy, but in case there was a calculation error, we don't want to carry that error to our next answer. So we're always going to go with what was actually given to us in the problem. Lovely. So let's get set up. Starting our Stoich statement, you start with what you know. This time around, I will use just liters. It will make it easier, otherwise at the end we'll end up with milligrams. That's okay, you can then change milligrams into grams, but I will show you that you can convert your volume. So for my volume, I'm going to get rid of that and I'm going to convert it into liters. So it's going to be 0.027 liters. And I just crossed that other one out so I don't accidentally use it twice. 0.027 liters of silver nitrate needs to be converted into moles, so we multiply it by our concentration, which then cancels liters out and we're left with moles. Once we have moles, we can then use our mole ratio. 2 moles of silver nitrate to 1 mole of silver sulfate. Silver nitrate and silver nitrate cancel out. Mole cancels out with moles. Now we need to convert moles into mass. So we will be using molar mass. The molar mass of silver sulfate is 203.94 grams per mole. So I'm going to multiply by 203.94 grams per mole, and that's going to cancel out moles, and I'll be left with grams of silver sulfate. Plug all of those values in, and I'm going to get an answer of 1.38 grams of silver sulfate. For the next one, okay, so we are going to be taking a look at this problem that you'll be working on by yourself. 7.4 grams of aluminum metal reacts with excess oxygen gas to form aluminum oxide. A. Determine the volume of oxygen gas reacted at STP. B. Determine the volume of oxygen gas reacted at 90 kilopascals and 125 Kelvin. Determine the mass, and then C, determine the mass of aluminum oxide produced. Okay, so I'm going to give you a couple hints here, and then I will be back with the answers. The first thing you're going to do is 1, determine balanced reaction. Okay, then from there, you're going to list your known and unknown, and then use that to find your answers. So I'll be back with the answers, and then you guys can check what you got. Okay, so what we did, you're first going to write your balanced reaction. I trust that you guys can do that. Then from there, you are going to use your balanced reaction. Actually, I will write this down. Plus 2 oxygens. No, it should be 3 oxygens. Gas producing 2 aluminum oxide. Yes. Okay, from there you list your known, which is 7.4 grams. And for this, you will be using the molar mass of aluminum to convert this into moles, into initial moles. For A, you will be using STP, molar volume, to find your liters of oxygen, which should be 4.61 liters. For B, you will have to find your own molar volume, and you should get 11.547 ... It's a mid calculation, so I won't round it, to get your 2.38 liters of oxygen. And then lastly, you will, for C, use molar mass of aluminum oxide to give you mass of aluminum oxide.